This week we're going to be working with exponential and logarithmic equations. We're going to do a very short review of what we worked last week, but also we will be working with logarithms using the calculator, and we're going to learn how to do a change of base because a calculator only has two logarithmic keys. The log, which is a log base 10, and the natural log, which is a log base e. So let's review first what we did, a little bit of what we did last week. If you take a look at your exercises from workbook from pages 190 to 192, exercise 16, if you have something like log base 2 of x minus 9 is equal to 9, and you are asked to solve the equation, you need to find the value of x. When you have it as a logarithm, what you have to do always, guys, is change it into an exponent. Remember, you take the base of the log, which is 2, and you convert it into the base of your exponent. The exponent would be the 9, and that would have to be, I have 2 to the 9 is equal to x minus 9. And then you need to isolate x. So if you need to leave this x by itself, you know that the negative 9, it's on this side subtracting. The way to take it to the other side is by adding. 2 to the 9 is 512, and I add 9, and that's how you get that x is equal to 521. Another example would be log. Remember, if it doesn't have a number as a base, then you should know that it's a base 10. So log of 2x minus 1 is equal to 2. So you would take the base 10, the exponent is 2, and that must be equal to 2x minus 1. And then once again, you got to leave the x by itself. So 10 to the 2 is 100. The 1 it's subtracting, I take it adding to the other side, so that would be 101. And then the 2 is multiplying, so I have to divide by 2, and that gives me 50.5. So that would be the value of my x for this equation. And the last example I want to review with is with natural log. Remember that if you have a natural log, you should know that it's a base e. So you start off with the base e, the exponent is the 2, and that must be equal to 4x minus 3. E to the 2, since in this example we're not using a calculator, e to the 2 stays as e to the 2. The 3 is subtracting, so I got to take it adding to the other side, so you have e to the 2 plus 3. And then the 4 is multiplying the x, so you take it to the other side dividing. And this right here would be your final answer, e to the 2 plus 3 over 4. Now you can try these. They're in your notebook, they are in your workbook, same pages, number 16. Log base 3 of 5 minus x equal to 4. Remember, you change it into log, or if you change it into an exponent, so you have a base 3 to the 4, it's equal to 5 minus x, and then you got to leave x by itself. So if this is subtracting, I'm going to take my x adding to the other side, and so I have x plus 81, it's equal to 5, and then the 81, I take it to the other side, subtracting, which would give me minus 81 plus 5, which is negative 76. And this example right here, the base is e, so you would have e to the 5 is equal to 4 plus x, and then the 4 is adding, I just take it subtracting to the other side, and you would get that x is equal to e to the 5 minus 4. Now, the next thing we're going to see, it's a change of base. Whenever we have logarithms, if you've noticed, the logarithms have a base. They must always have a base. But the calculator cannot give us a base other than a base 10 or a base e. Or there's cases where you need to change into a specific base. And that's where we use the formula for change of base. If I have any base and I want to convert it to a specific base, let's say I have log base b of x and I want to change it into a log a, all you have to do is put log of the base that you want of x over log of the same base that you want of b. In other words, if I have log base 5 of 32, you can change this into a log base 10 by doing log of 32 over log of 5. Or I could have changed it into natural log. I could have said natural log of 32 over natural log of 5. And that's going to give me the exact same value in the calculator. You literally look for the key that is log, you push log 32 divided by log 5, and you're going to get approximately 2.15. I could have changed it to whatever base, but in this case, the idea is to change it into a base that will allow us to use the calculator. So the only two bases that you can change it into is log base 10 or natural log of x. With that in mind, now we can work the exercises from page 192 to 194, which is exercise number 17. If I give you this equation, 2 to the x minus 9 equal to 910, the first thing that we would try to do is put this 910 to a base 2, but it's going to be kind of hard. So if we are using the calculator, we can go ahead and use a change from exponent to logarithm. So you would have log base 2 of this number, it's equal to x minus 9. So I have so far log base 2 of 910 is equal to x minus 9. Now x minus 9, this negative 9, I can take it adding to the other side, and you would have 9 plus log base 2 of 910. If you are allowed to use a calculator, this is the exact value, but if you are allowed to use a calculator, then you can do a change of base here so that you can evaluate it. And you can change log base 2 of 910 into log of 910 over log of 2. You put it in the calculator and you add 9 and you get approximately 18.83. Another example would be this one. 661 to the 5x is equal to 23. I change this into a log. So it's log base 661 of 23, it's equal to 5x. I need to leave x by itself, so the 5 is multiplying, I take it dividing to the other side. Log base 661 of 23, I can do a change of base for this one by doing log of 23 over log of 661. And once I have that result, I can divide by 5, and you're going to get that x is approximately 0.0956. Another example would be like this. 10 to the 2x is equal to 67. The base is 10, so I can just go ahead and say that its log of 67 is equal to 2x. The 2 is multiplying, I take it to the other side dividing. In this case, guys, since it's already a log base 10, you don't need to do a change of base because this you can literally put it in the calculator. So you would literally put log of 62 in the calculator, and that result you divide it by 2 and you get 0.913. Here's another example. I change this to logarithms. I would have natural log of 911, it's equal to x plus 4. The 4 is adding, so I take it to the other side subtracting. And same thing happens here. Since this is already in a base e, and you can use that in the calculator, you don't have to do a change of base. So you would just put it in the calculator directly. X is equal to negative 4, plus you push the key natural log 911, and you're going to get approximately 2.8145. You can try it in your workbooks, guys. At letter B, 5 to the x plus 1 is equal to 806. Change this exponent into a logarithm first, so you would have log base 5 of 806 is equal to x plus 1. This one is adding, I take it to the other side subtracting. Now this logarithm has a base 5, so I need to change it into a base 10 or a base e. So I'm going to change it into a base 10 by doing log of 806 over log of 5. You put it in the calculator, you subtract a 1, and you get approximately 3.16. And the other one that you can do in your workbook, guys, try it on your own first, is log base 10 of 474.4, it's equal to 11 minus x. I take this x adding to the other side, and this I take it subtracting. Now this log is already a base 10, so I don't need to do a change of base. So I just do 11 minus log base 10 of 474.4, and you're going to get that x is approximately 8.32. And here's another last example. If I have a base e to the 7x is equal to 550, You can change it into natural log of 550. It's equal to 7x. The 7 is multiplying. I take it dividing. And since I already have a natural log or a base e, I don't need to do a change of base. You can just do it directly in the calculator, natural log of 550 over 7. And that's going to give you approximately that x is 0.9014.